aren't we solving it? Yeah. We're finding the x-intercept. So there's a couple different ways you can do it. Now, some people I know just typed it into their calculator and found the x-intercepts. That will work. However, if it does, that will work. That's not a bad method, but also we should be able to do it algebraically, because what if it can't be found that way? Okay, so first of all, it's quadratic, so we know we'll have two solutions. So can we go like this? This is how we learned it. Now isn't this in vertex form? Remember when we completed the square? And then on day 2, didn't we solve? Yeah. So we complete the square to get it in vertex form. Then we solve the quadratic. So don't we just set it equal to 0? You guys watch. This is how you do it algebraically. You're going to have some today that you have to do algebraically. So you should all be going through this with me. So what would we do? Isolate this, right? We'd add 9 to both sides. So we have x minus 1 squared is equal to 9. Then what will we do? Square root. Aren't we trying to solve for x?
Yes.
So we square root both sides of the equation. Our root cancels out with our power. We have x minus 1 is equal to?
9. 3.
What else?
Plus and minus.
Negative 3. Good. So the square root of 9 is plus and minus 3. Because remember, what this really means is what squared is 9? 3. What else squared is 9? Negative 3. Are we all good?
Yes.
So then we split this up.
Plus.
X minus 1 is equal to positive 3. X minus 1 is equal to negative 3. Are we all good?
Question. Why can't you add 3? Add 1, sorry.
You can. That's what we're going to do now. So now to solve for x, won't we add 1? Okay. So we have x is equal to 3 plus 1 is? There's one of our x-intercepts, and then we'll add 1 here as well, right? So x is equal to negative 3 plus 1.
2.
Negative 2.
Negative 2. Questions? Can we do it algebraically now? Yikes. Okay, awesome. Make sure you can do both ways. And then, yeah, you could try and check it on your calculator. Okay, so just a review of everything we've learned in this unit, because like I said, we have today, tomorrow, we're done. So a central angle is an angle that starts at the very center of the circle and opens up on an arc. A central angle is equal to its intercepted arc. So if this is 30 degrees, arc AB is? 30 degrees. And it goes backwards. If this is 90 degrees, what's angle? 90. Good. So then we learn how to find the physical length of the arc. Given a central angle, we can find the physical length of the arc. You take the radius times theta, as long as theta is in pi radians, right? So that was 60 degrees, we'd change it to radians, right? You do that by 60 times by pi over 180. 60 over 80 is 1 over 3, right?
Yeah.
So that's pi thirds, right? So we just change our theta to radians. Okay, then we learn how to find the area of a full circle. I'll be filling in this entire inside, pi r squared, right? Circumference of the circle, find the physical distance of the outside of the circle, 2 pi times the radius. Then to find the area of a section of a circle, you take the section divided by the full circle. That's why it's theta over 360, and it's always pi r squared for area of a circle, right? Then we learned, if you have a tangent line, tangent means it touches the circle in one spot. If you have a tangent line and you drop a radius to the point of tangency, which is right there, then it will create a 90-degree angle, right? And then we learned the past 2 days, if you have an inspired angle, an angle that starts on the outside of the circle and opens up on an arc, then that angle will be half of the amount of the intercepted arc. So if this is 60 degrees, what would theta be? 30. If theta was 20, what would the arc be? 40. Okay, are we good? Okay, so today we're learning more with segment lengths, okay? So we're going to be dealing with segment lengths of chords. Now remember, a chord is something that cuts through a circle, so it touches the circle in 2 spots. So look right here. Do you see this highlighted yellow thing here? That's called a chord. Are we all good with that? Okay, that's a chord. So the rule is, if you have a chord, which is also called a secant line, from here to here is a chord. It touches the circle twice. If you have a chord, which is also called a secant line, and you drop a radius at a 90-degree angle. So do you see the purple line? From here to here, I dropped a radius at a 90-degree angle. As long as you've dropped it at a 90-degree angle, then it will cut the chord into 2 equal segments. So this piece will be equal to that piece, as long as that's 90 degrees. Does that make sense, everybody? It cuts the chord into 2 equal segments. This would be equal to this. So if this was 6, what's this? 6, right? Now here's what a common mistake students have issues with. They will change this rule around in their head and say, oh, so this is equal to this. Not true. It does not cut the radius in half. Does everybody understand that? That was not true. I'm going to erase that. Oops.
Oh my.
Okay, it'll be a quick fix. Okay. Now also one fact for you. As long as that was dropped at a 90 degree, as long as the radius was dropped at a 90-degree angle, it will cut the chord into 2 equal segments. Also, it's actually going to cut this arc and this full arc into 2 equal segments. So this arc is 25 degrees. What arc is this? 25. Are we all good with that?
Yeah.
Okay, sweet. So, just looking at this back and forth. This is a radius being dropped at a 90-degree angle. There's my chord. So isn't it cutting the chord into 2 equal segments? Yes. So what would this be?
6.
6. Good. Now, backwards. We're given a chord. It's 8 is equal to 8 and 8. Aren't they equal?
Yes.
So what do we know about this angle? 90 degrees. Are we all good with that?
So does that mean the other angle is also 90 degrees?
This angle is also 90 degrees. Yep,
That's
good.
180 right there.
Good. That would be a straight line angle. Makes sense. 180. Good. So then my question is, if this was 30 degrees, what's this?
30 degrees.
30 degrees.
Yep.
Okay. Question. Question. Does this equal, if this is 2, what's this?
2.
Is it 2?
Yeah.
No! We just learned it doesn't cut the radius in half. So we would say, not sure.
But you
Right?
put the lines there, so you
I
can't
was,
trick us.
no, I was asking you. So I'm asking you. But we don't know, right?
I hate
Well,
yellow.
so see the other side of the 90-degree angle, would that be 30? Like,
No, this is an arc.
I see what you're
This
saying.
was 30 and this was 30. Those are arcs.
No, I'd be. Okay.
Okay. Okay, here we go. So let's start going with some examples here. So look, don't take notes on this part because it's just going to be better for you to watch. Solve for x and y. So first of all, the first thing I notice is a radius is what?
5.
5. Now if I draw a radius here, what will it be?
5.
What about here?
5.
So what's y?
5.
Y is the radius is 5, y is 5. Yeah?
yes.
Okay, now let's go with x.
6.
How do you know it's for sure 6?
The 6 plus 6 is equal.
Good, we have a chord, we have a radius dropped at a 90-degree angle. If this is 6, this is 6. So x is equal to 6. Questions? Very straightforward. Okay, next one. Find x and y.
Hey, x is 6. No,
Okay,
x,
so you're saying x is 6, but how did you know?
because half of 12 is 6.
So you're saying a radius is 6.
Right.
Anywhere we draw a radius, boom, right there.
Y is 3.
6, so right here is,
6.
so x is equal to 6. Does everybody understand why?
Yes. But y is not 3.
Why? What's y?
3.
3, good. If this piece is 3, then this piece is 3. Good, because it was cut at a 90-degree angle.
Didn't think you could keep it.
Y is equal to 3. Questions?
Can you work?
No? Solve for x.
Cox.
How'd you know it was 5?
3 plus 2 equals 5.
Oh, no matter where we draw a radius, 5. What's that?
5.
5. X is equal to 5. Are we all comfortable? Can we say anything about 4? Does 4 have anything to do with the radius? No, so be careful. Last one. What's that?
6.
How'd you know it was 6?
1 plus 2 equals 3.
Oh, our radius is 1 plus 2. Therefore, 3 and 3 is... You're an animal today. On fire, yeah. Any questions on that? 1 to 12. So let's look at this one here. So we're asked to find x. So could I do, so this piece right here, just let me clarify, this piece is 4 and this piece is 3. So could I say those 2 pieces add up to be a radius?
No.
No, right? This segment has nothing to do with a radius, so we can't do that. Does everybody understand why? Now we need another radius, so let's think about it. Don't we know that if this is 4, what's this? 4. Now don't we have a right triangle? So since this is sides of a triangle, can't we use the Pythagorean theorem?
Yes.
Okay, so let's do that. So the hypotenuse is x, so make sure you're really careful in this one. The hypotenuse is x.
3 squared.
3 squared plus 4 squared is equal to x squared. Make sure you set up the hypotenuse right. So that'll be 9 plus 16 is equal to x squared.
You're always trying to find the hypotenuse.
Not always. Nope. That's why we're going to do some examples. Just don't get in head. Don't say, okay, I get it. I'm just going to go. Okay. So everybody, are we good so far? What is x equal to?
Hey, 5.
No. Yeah. What else?
Plus and minus 5.
Good, plus and minus 5. For this problem in particular, when we take the square root, we have to put the plus and minus. For this problem in particular, do we throw out the minus? Yes. Would we have a radius of a negative 5?
Yes.
We would not have a radius of a negative 5. Therefore, we throw out negative 5. Are we good?
Yes, ma'am.
Why do we have to put the plus and minus?
Hey,
Because
practice.
that is true, right? X is equal to plus and minus 5. We're solving that, right?
Oh, if it's a quadratic.
It is quadratic, right?
Okay.
Okay. Next thing, next problem. So find x. So x is this piece right here. So let's think about this. If this is a radius of 5, what will my radius right here be?
5.
5. And if this is 90 degrees, isn't this 90 degrees?
Yes, ma'am.
Then are we just dealing with another Pythagorean theorem problem?
Yeah, real fast.
Careful though, your hypotenuse in this one is 5. So we'll be doing side 1 squared x squared plus side 2 squared is equal to the hypotenuse
5
squared.
squared.
So we have x squared plus 4 is equal to 25, yeah?
Yeah. Minus 4.
X squared is equal to 16. X is equal to,
Whoa.
What? Like 4?
subtract 4 from both sides, 16.
That would be 21.
21.
Okay. Danny.
So we subtract 4 from both sides and we get 21. Square root both sides and we get
4.5825.
4.5?
4.
4.54?
4.582575.
Wait, I don't want to know the whole decimal. Round it to the first decimal.
4.6.
4.6. So we got plus and minus 4.6. We'd only keep the plus minus, the plus answer, right? 4.6.
Yeah.
Last few, stay with me. Solve for x. So people do not, they have a hard time. But let's just, use the knowledge that we do know. Is your radius, no matter where we draw it, the same?
Yes.
So if this is 6, what's this?
But that's not the radius.
Yeah.
It is. It starts at the center of the circle and goes out. My picture might not be perfectly drawn. If it starts at the center and works its way out, it's a radius.
So it doesn't have to touch the end of it.
No, it does. It touches. Look. Center to the outside is a radius.
Oh, I thought you were talking about.
Okay. So now, let's see here. We're not going to be able to find x without using the Pythagorean theorem again, right? So quickly, so we'll be doing x squared plus 4 squared equal to the hypotenuse, which is 6 squared. So we have x squared plus
16.
equals 36, right? X squared is equal to 20. X is equal to plus and minus 4.5. Throw out the minus, x is equal to 4.5. Yeah? Are we good with that? So just besides the point, if this is 4.5, what's this? 4.5. Last few. Okay? You're going to be able to finish this in class. Stay with me. So solve for x. Now, careful. X is this piece from here to here, right?
Yeah.
Okay. Now we know our full radius is 10, right? So from here clear down to here is 10, but we have no idea how that's split up, right?
Right.
Okay, so we're going to have to think about this one. Oops, this should have had a 90 degrees there. Okay.
That makes it way easier right there.
Well, yeah, kind of. So now let's think about it. Can I personally choose to draw my own radius right here to here?
Yep.
Yeah, right?
Oh, yeah.
So what will that be?
10.
10. Now think about it. If I go through and use the Pythagorean theorem, that's not going to find x, but won't it find question mark?
You can find x.
And then once you know question mark, then couldn't you find x?
Plus x squared.
Are we good though? Do you understand how right now I can't solve for x in any way?
Right.
Okay, so I'm going to just first say, okay, I'm going to solve something that's in the triangle vicinity here. So I'm going to do 5 squared, right? Plus question mark squared is equal to 10 squared, because 10's our hypotenuse. 25 plus question mark squared is equal to 100. Question mark squared is equal to 75. I subtracted 25. What's question mark? 8.75? Is it 7.5?
Oh my gosh, guys. I'll just do it.
Oh, okay, 8.7 then. Okay, so we know that question mark is 8.7. We throw out the minus. Now that's not our answer though.
Yeah, you got a minus.
This is 8.7. So how could we find x?
1.3. 1.3.
10 minus.
Good. The full radius is 10. So we know 8.7 of the radius is right here. So how much is left over? 10 minus 8.7 is 1.3. Questions?
There we go.
Same idea though, right? Okay, I won't go through it, but same, people couldn't do it first hour, that's why I added this.
Well,
What
first
would we have to find first?
6.
What would we have to find first?
Radius.
The radius is 6, so isn't that 6? Now, but that only lets us find this.
Right.
Once we know that, we take
That's
the
6.
radius minus that, right?
Right.
Yeah.
Are we all good? Do you want me to keep going with this one?
All right.
Okay, so 6, so we're doing, question 4, sorry. So we'll be doing, 4 squared plus question mark squared is equal to 6 squared. Question mark squared is equal to 36 minus 16, right? 20. So question mark's at 4.5, right?
Yes.
Plus and minus?
Yep.
So we throw out the minus, so this is 4.5. So now to find x, won't we do 6 minus 4.5?
1.5.
1.5.
Isn't our full radius 6? We know this piece of the radius is 4.5. What leftover does that give us?
1.5.
Wait, was that 4.5?
Yeah,
that in-
30 to 20 is 4.5.
Are you sure?
I'm almost positive.
It is? Okay, so we get 1.5, right? So x is 1.5. Okay. Sweet. Okay, last thing. Do this problem real quick. Go. Okay, so, guys. Were you guys able to get it?
Nope.
Brendan did.
Brendan.
First hour did.
First hour.
Do you want me to give you another second?
AC is 60.
Go through it.
Correct.
Okay, so arc AC would be this way because otherwise it would have been not named arc ABC. So what would AC be?
Oh, 200.
300, okay? If this is 30, this is caught at a 90-degree angle. What did we just learn about these?
They're the same.
So if that's 30, then that's 30. So then what would this be?
300. Okay, now that was stupid easy.
300 degrees, right? 360 minus 30 minus 30.
Oh, okay, I get it.
What is side DC?
Right there.
3. If that is a 90-degree angle, we have a radius drop on a chord at a 90-degree angle. Cuts the chord in 2 equal seconds. 3. Guys, that was easy.
It was.
Okay, finish the worksheet, and then these are the required problems that you will do on the back. You'll finish that really pretty quick. Then you have to do these problems additional on the back. Like, you'll write them down yourself.